off we go. So welcome everybody to CSCI 40. I'm happy you're here. So first of all, I'm going to give you everything you see today on Canvas. You're going to get all the slides, all the code. I'm sorry I can't see you guys over there. We'll figure this out somehow. Just move around to see who has questions. You'll get all this and all the code that I write on Canvas. Should be self-explanatory, hopefully. Today's lecture is going to start out a little boring, and I'm sorry. It kind of has to be like that. We have to do that thing where I just explain the class, and we'll get through it together. I'll introduce myself as well, and then we will get into programming today, which is exciting. Okay, so look forward to that. Let me give you one slide about me, and then we can be done with it. So, hello everybody. Welcome to CSCI 40. My name is Lon Nichols. I use he/him pronouns, and I will honestly respond to whatever you want to call me. You can call me, oh gosh, I plug a mouse in, it's not happy. I'll respond to Mr. Nichols, Dr. Nichols, Professor Nichols, whatever you want to call me. But honestly, if you're feeling up to it, I'd prefer it if you just crossed all these out and call me by my first name. Please call me Lawton, okay? I'd like to earn your real respect. I don't want your fake respect with these titles, right? So I went to Fresno State for my undergrad, or my background, I guess. It's not too far away, right? And then I transferred to UCSB, UC Santa Barbara, for grad school. All of my degrees are in computer science, master's, PhD, bachelor's. So hopefully that means I can teach you a little something. We will find out soon. All right, so this is my cat. His name is Lonzo. He's much bigger now. This is him when he was a kitten. But I named him after a famous computer scientist / mathematician. His name was Alonzo Church, and he was the PhD advisor. If you've never heard of him, he was the PhD advisor of Alan Turing, who you should have heard of by now, hopefully. So dedicated my firstborn son to the cause. And what else do I want to tell you guys about me? I don't know. I exist outside of campus, too. I'm a real person. I like to run, go hiking, play guitar, normal human things. So we can talk about those later. But yeah, that's me. I'm glad you're here. Nice to meet you. So I guess thank you in advance for putting up with me this semester. We'll get through this together. We live in these weird post-COVID times. Is that a question? Yeah. You can do whatever you guys want. This is brand new to me too. I'm gonna try and get us a curtain because I know the glare is probably horrible. Yeah, they didn't plan this too well. Sorry. So yeah, sit wherever you want to sit. I don't know what I'm gonna do about this because I can't see you guys over there. How's this gonna work? Yeah, I have a few questions for you actually.
Yeah.
How do I lock the door open without using the? Yeah, no, I can unlock it.
They use some of the rooms have
Yeah, someone has levers.
this building has it.
But I haven't figured out if there's a lever here.
Yeah, exactly. I'm like,
How do you lock that? Well, I need to get a key. And also, this Ethernet port doesn't work.
yeah, I know. That's what we're working on.
Oh, cool. No worries. Okay, do your thing.
Actually, this is not working either. So.
Oh, it did turn on the display.
Yeah, but it's not working right.
Oh, okay.
So, are you using your laptop then?
Yeah, I'm just gonna use my laptop for today.
We're still working on it.
Thank you. Yeah, no worries. Yeah. So yeah, we'll all figure this out together. With enough people, we will survive. So yeah, let's get on into it. Let's do the boring stuff, and then we can go do cool things. All right. So let's talk about logistics. I'm so sorry. I'll go fast so that we all stay awake. Okay. So this is an in-person class, so I have to take attendance. All right. We'll do that soon. Sadly required to. I have to drop you if you don't show up. But after the lecture is over, there will be lab time. All right. Don't trust whatever self-service told you. There's a lab every day. All right. There'll be time for that every day. Just whenever the lecture's over, that's when the lab starts. Okay. That's how that'll work. And nobody's told me otherwise. So if you finished all your work in the class and it's lab time, you can just leave. That's the loophole. That's how we'll do it. Okay. My drop policy is if you miss 3 classes in a row, that's pretty lenient, right? Then I'll drop you. All right. Because then you're definitely not showing up. And if you miss this first class, of course, which none of you are, then you'll be dropped too. Okay. And I'm lenient if something comes up or you get sick, you have a doctor's note, whatever, just let me know and that won't count towards one of the 3. Okay. So yeah, lab starts whenever lecture is over, and in between lecture and lab, there will be a little break. We're required to get a break, 10 minutes. And I'll just let you guys take it whenever you want. after today. Today there will be a scheduled break, but after today it'll just be like whenever you want to take it, you can take it. Okay. So I like to run my classes like a discussion, so I'm just not shouting out at you guys all day long. So please, if you have a question, just shout out to me, raise your hand, whatever you feel like doing, and we'll get your questions answered. Okay, it's more fun that way. So it's not an online class. Let's talk about expectations. All right, this is a bit of a harder class. All right, so I want to make sure you're mentally prepared for it. All right, if you've never programmed before, and this is the class for you, if you've never programmed before, it's a completely different way of thinking. It's something you have not done yet. It's going to melt your brain a little bit. All right, and that's to be expected. So just to get it all in your head, I have to give you a decent amount of work. And then also to get it to transfer, I'm required to teach you a bunch of things that I don't really have control over. So there's going to be a decent amount of work in this class. Please prepare for it, set aside time. Okay. One nice thing, or not nice, I guess, depending on what kind of person you are, this class has nothing to do with memorizing things. It's kind of nice, in my opinion, at least. There's no, like, I have to memorize all these formulas and only then will I do well on all the tests. No, it has nothing to do with that, which is awesome. Every program that you could write could be done differently. Like, there's a million ways to do the same thing. Programming is like art, in my opinion. It's really cool like that. So that'll be fun, getting to show that to you. And I'm not trying to scare you away. I think all of you can be here and succeed. But if this is like, you're taking too many classes right now, the workload is too much with this extra one, I also teach CSCI 1 here, and I'm happy to switch you over to that class. That's a much gentler introduction to programming to prepare you for this one, and then you might be able to do it a bit quicker and not have to spend as much time. So consider taking CSCI 1 instead of this class if you feel like you're in that boat. But yeah, this class is 4 units. It's a major level course, and so that rule that applies to units is going to apply to this class. So if you've never heard it before, like 4 units means you're spending 4 hours in class every week. And then you're supposed to double that, and that's how many hours you're supposed to spend outside of class doing work or study. Okay? So that's why like 12 units is a full-time load. That's what that means. You've never heard that before. So yeah, I'm not trying to scare you away. I just want to make sure you know what you're getting into. Okay? Getting yourself into. And I'm going to be here to help as much as possible. I'll have office hours today, for example. I'm on Discord way too often. I'll be here to help you, and your peers will be here to help you too. Okay? So please stay. I'm just going to go lightning round through all this stuff. So please just let me know if you have any questions about anything. Shout it out. There's a technology loan program here. So you're going to need a computer to do your work on at home. And if you need a better one, the library is checking out laptops to you guys. So consider that if you need it. Take advantage of it. They've got plenty. They also are checking out little hotspot internet routers, which is really cool. So if your internet connection is bad at home, consider checking one of those out. They're also checking out like calculators and stuff for a math class. Definitely take advantage of that if you need to. It's good stuff. But yeah, let's go to the slide that you probably are all here for, the most important slide of the day. All right, let's talk about how your grade is going to be calculated. So, hopefully you saw that to get to all of these pages, actually look at the syllabus, you have to go to the modules first. So hopefully we all did that. And I'm forcing you to at every page. Okay? So like these two you got to look at to unlock all these, to unlock this. And so that's just how that works. Hopefully you saw that. And yeah, let's go to the syllabus. Please read it. I'll fast forward to the cool place, the place that you care most about. I wonder if I can I'll try that later. But let me just scroll on down here. Boop. I passed it. Okay, so yeah, here's what your grade is going to be coming from. Okay, so we've got homework from your textbook, which you have to buy, and programming assignments. Those are going to happen pretty much every single week. And here's how it's going to be broken down. So I'm going to have you read chapters of your textbook. It's an interactive textbook, and that's how you get credit for reading it. That'll be 10% of your grade. Okay. There will also be programming questions from the textbook, and those are called Xi Labs because it's called a Xi book. Who knows why? That's another 10% of your grade. All right. And then the bulk of your grade is from assignments. Is going to be from programming assignments on our class server. Okay. That'll be 25%. And that's what every one of these guys is preparing you for, to do the work on the class server. Okay, so we'll get you on there later today, and yeah, Hopefully you also saw the little check-in survey, which is cute. This first week's one is just me trying to get to know you, so please fill that out. I'm going to give you one every week. Usually it's going to be questions like, what are you struggling on right now? How do you think you could improve on what you're struggling on? Stuff like that. So it's me forcing you to psychoanalyze yourself, and that's good for both of us because it's going to help you like get your problem solved, and it's also going to help me to know how to better teach the class and get you to not have those problems. So that's the goal with those. So just do them every week. It's an easy 5% of your grade. Dun, dun, dun. And then we'll also have some tests. So we're going to have 2 midterms, and each of them will be worth 15% of your grade. There's going to be, the first one will be on week 6 of class, so it's like a third of the way through the semester. And the other one will be week 12, 2/3 of the way through the semester, and then the final exam, 3/3. Nice and evenly spread out. And yeah, that's 30% total. And then the final exam at the end of the semester will be 20% of your grade. Okay? Any questions about that? Because that's probably the most important slide for a lot of us today. I understand. Does that make enough sense? All right. I will be giving extra credit. I give at least a letter grade's worth of extra credit every semester in assignments. And then also, hopefully you saw when you joined our Discord that there's an ACM club on campus that has their own Discord that you could join. And they like to give workshops every so often throughout the semester. And every time you guys go to one of those, you give me proof, and I will give you half a percentage point towards your final grade and extra credit. All right? So it's an easy way to get some credit and learn something cool. So I highly encourage you to attend those. I can show you where you can find out more about those if you haven't found the right channel yet on their Discord. I will cut you off at 10% extra credit, though. So that's as much as you could get in the class. Okay? Don't do any more than that. And then finally, the final exam date, because we have a scheduled class time, we have a scheduled final exam time. And if I read the table properly, please double check me, but it should be the Tuesday of finals week starting at 2 p.m. So not normal class time. You got to come here at 2 p.m. Sorry, it is normal class time, sorry. But it's not going until the normal class end time, excuse me. So it's 2 p.m. to 3:50 p.m., apparently. Okay? So that's how long our final exam will be on the Tuesday of finals week, and it'll be in this classroom. Okay? Any questions? Any of this page? We still good?
Yeah.
All right. So let's talk about some policies of mine because I have some weird ones that some other professors might not have used before with you guys. One thing that I want you to just prepare for is every assignment in this class, except for the check-in surveys, which are going to be due at 5:30 p.m. on Fridays, will be due at 5 p.m., not midnight, 5 p.m. Okay? That's when all assignments will be due in this class. Canvas says when, so you'll be able to know, but just keep in mind, mentally prepare every assignment in this class due at 5 p.m. All right? And the reason that I do that is because so many technical issues happen around the due date in a computer science class. I think you can imagine things go wrong when people are trying to turn stuff in and they're having trouble. So this is to make sure that I'm awake when those issues are happening. And I'll also usually be having office hours around those times to help you. Okay? So that's the reason I do it. And it's just a win-win for both of us. And then we get to have a weekend as well on Fridays. So works for me, works for you hopefully too. I do make some exceptions though for certain students. So let me know if you fall into any of these categories. If you work at least half time, so 20 hours or more per week. School doesn't count though. If you're taking like 20 units, that's totally your fault, right? Some of us have to work though. And so if you are a worker and you work at least half time, then I'll give you an extra 7 hours on all your assignments. So it really will be due at midnight for you, okay? If you work at least full time, if you work more than 40 hours or equal to 40 hours every week, or you do something that's the equivalent of a full-time job, like you care for a child, then I will give you an extra 15 hours, okay, towards your assignments. And so you could either stay up late or wake up early and you have some more options to get it in. And I hope we can all agree that people who fall into these categories deserve the extra time, okay? So just let me know if any of these apply to you, and I'll get you in the right group and give you those extensions, okay? They're just for assignments, though. Everybody's taking the tests at the same time. Okay? So that's my date policy. I'm pretty lenient when it comes to late submission, so every Zybooks assignment, both programming and reading, every lab on the class server, and every check-in survey, I let you turn in late if you miss one, up to the last day of instruction. So you have a chance to make up everything before the semester ends. And that's extra special and important because everything builds on top of itself in this class. And so if you miss an assignment, you really should redo it because you're going to be lost in future assignments. Okay, that's important. But the give and take there is the second you turn something in late, I'm taking off half credit. Okay, so that's the trade-off. But I still think it's pretty lenient, and of course, 50% is way better than 0%. Okay, so highly encourage you to take advantage of that. When you turn something in on zyBooks late, zyBooks hates Canvas, and so it's going to transfer your grade as a 0, and you just have to tell me. Just remind me. Send me a message on Discord or something, and I'll give you the right grade. I'll go in and manually change it to half credit. Okay, so that's my late submission policy. Again, just shout out if you have a question about anything. I'll also be dropping a lot of your lowest scores, so if things go wrong, or you do have to turn something in late, the 50% is not going to ding your grade. So I'm going to drop your 3 lowest labs on the class server and your 4 lowest zyBooks readings and Labs assignments. Okay, so that's quite a bit. Still make them up though. Highly encourage. Okay, so if you have a bad week though, it's not going to affect your grade, which is good. So there's that. And then yeah, while we're talking about your textbook, let's go there. So it's a virtual interactive cool thing. zyBooks. Oh, actually, no, let me show you how to get there right, not as a teacher. So to get to your book, you have to go to one of the zyBooks assignments, like this Chapter 1, Chapter 2, or Chapter 1 Zylab. Let's go to the first one, maybe. And then there's this button. Hopefully you found it already. It's like loaded in a new window. And if you haven't bought the book yet, it'll give you a link to buy the book. Or if you buy it from the bookstore, then it'll ask you to put in the code. You have both options once you click that link. And then it'll take you to the actual assignment. Okay, so that's the assignment itself. You can buy it either on the website itself or the bookstore. Highly encourage you to buy it just from the website itself because I've heard horror stories of students having to wait for 2 weeks to get a piece of paper with a code on it mailed to you, physically mailed to your house. Which makes no sense at all. They should just email it, but they can't for some reason. So I have no clue why. But try to buy it from the website if you can. Yeah, and just follow the link in the first assignment to buy it. And then as you're working through this assignment, you should go out to the table of contents. Like here's the table of contents, and here's an assignments tab down there. Can we see that? Yeah, assignments tab. And then this shows you exactly what I'm asking you to do on this chapter. And you can see your current score, and it's going to keep on transferring to Canvas as you complete it before the due date. All right? The due date on zyBooks is wrong because it's set to the last day you could possibly get late credit, which is the last day of the semester. So don't pay attention to this due date. Pay attention to the due date that's listed on Canvas. Okay, so that's that. And so you can see what assignment, what chapters I want you to read. It's really cool. You can see all the assignments, for example. And yeah, there's an order to it all. And it's really cool. It's virtual, it's interactive, it's awesome. And I don't know, let's just go to the first part. And they got cool little animations, and it's really just going to help you learn. This is the greatest textbook I've ever seen for this class, to be perfectly honest. So it's really worth it, and it's going to help you a lot. Students tend to love this book. Okay, so yeah, that's that. I've put actually every single zyBooks assignment down at the bottom of our Canvas. So if you have no life, you can start on all of them right now if you'd like. Okay, so it's always nice to read ahead, I guess, but definitely pay attention to the due dates and complete them by then, if nothing else. All right, so yeah, that's our textbook. Make sure to get it. We got our first assignment due next week, I think. And again, shout out if you have questions about this stuff. I'm trying to go fast so that we stay awake, like I said. So also we have Discord for this class. That's how we're going to interact with each other. So Discord, and this laptop's pretty slow. We'll see. Maybe as it starts up, I can try and break this display. I can see you all. Nice to meet you. Exactly. So, all right. So here is our Discord. The welcome channel and the guide channel are the only things you'll see when you join it. You gotta scroll up to the tippy top, click the 100 emoji, click the cat for CSCI 40, click your pronouns, and then you should unlock a lot of stuff down here. So general announcements, random, and the CSCI 40 channel. So that's where you'll interact with your peers. Okay, it's a great place. It's wonderful. So highly encourage you to ask questions there. Ask questions in our CSCI 40 channel. Public, that's a public channel, of course, everybody in the class can see. Ask it as much as you can, ask a question there, right? Because then when it's 3 a.m. and I'm asleep, then you're going to get help pretty quickly. The one thing I want you to not do, though, and please just use your judgment, I trust you, don't share an entire answer. Don't share an entire file's worth of code, something that's going to give something away, because that's completely unfair to the other students, right? It's going to give something away, and that just ruins the assignment. So when you have to ask a question and it requires you to share a ton of code, that's when I want you to message me or our tutor, who will be coming later today, or like go to the tutorial center, have somebody that's not in the class see the code, right? To talk to me, you can click my name. There should be a message button that appears. I can't message myself. You can right-click me, whatever you need to do. But that's how that works. Like if I wanted to message Max here, okay, right-click him, go to message, stuff like that. Okay. So that's how I want you to do stuff. Send me a direct message when you'd be giving away an answer, right? And you can't post it publicly. But do your best to make a public version of your question when you can, right? I also highly encourage you to talk to me via Discord rather than email or Canvas messages, because that also goes to my email anyway. You can imagine, hopefully, how disgusting every teacher's inbox looks and how easy it would be for me to miss something from you. So Discord, maybe you saw it, like on the left side, I can see little notifications. Those were students who asked me questions that I need to respond to. Super simple for me. So highly encourage you to talk to me on Discord, please. There's that. And yeah, there's going to be office hours. I'll try to have some today after class. That'll be the plan at least. And I want you to come to them. So office hours, this one. So I'll be having office hours. This is my plan for the schedule, all these green times. After today, for example. My office is just down the hall. I haven't actually been in it for more than 2 minutes yet, so that'll be fun. Brand new, like the classroom. But this is when my office hours, I want them to be. They might change because I'll have like meetings assigned to me. We'll see. So just keep coming to this page. And they'll be both in my office, at least these guys, both in my office and on Zoom always, because I have online classes too. So if you just want to go home after this, you don't want to come to my physical office hours, you can just click the Zoom link as well. Okay. So plenty of ways to come and get your questions answered. There's also the tutorial center on campus, and I'll have our tutor, our embedded tutor, explain more of that later once he gets here. So yeah, that's when office hours will be. Come get help from me or the tutors in the tutorial center. It's a great place. Yeah, the last thing I want to say before we kind of get into the lecture itself is you're going to get stuck as you program. Right? It's just a fact of life. It's a completely new way of thinking. It's going to be hard, especially at the start. So let's make sure you guys get help. All right. Here's the setup. Let's set aside an amount of time. Okay. So let's say if you've been stuck on something for 30 minutes, you've just been staring at the screen, you have no clue what to do, you have not made any progress at all for 30 minutes. That's when I want you to get help. All right. Ask a public question on Discord. Come to my office hours. Go to the tutorial center. Do something. And ask a question, right? So you should not be stuck and staring at your screen for 2 hours like I was when I was an undergrad. I'm trying to get you to not be like me, okay? There's no virtue in that. So please, get help when you need to. After 30 minutes, it's not worth it just staring anymore, okay? Because, of course, it's my job, right, to get you on to the next issue that's going to take another 30 minutes, okay? That being said, though, you'll find a lot in this class that you'll be staring at your problem for 29 minutes and 59 seconds, and then you suddenly have a flash of brilliance. That's the plan, at least. Okay, that's going to happen a lot. It does take a while for everything to churn in your brain, and then eventually you just get it. And that's just programming in a nutshell. It's weird like that. Okay, so that, I think, is what I wanted to say. Please just get help when you need to. I'm here to help. I'm happy to. Okay, and I think that brings us to the end of our logistics section. We made it. We're still all not snoring, I hope. Are there any questions about any of that we talked about? Yes? It is on Canvas. It is it's on this Discord info page. Yeah. All right, so if we're ready, well, let's move on to the second bit of class here. Let's go and talk about the class website, which maybe you've been on already. I don't know. So first of all, this is a bit of a confusing thing. I've made you 2 accounts in 2 places. We have a class website, and a class server. All right. One is one place, one is another place. I've made you an account with the same username on each right now and the same default password. So it's a little confusing because you're totally possible that you could change the website password to one thing and the class server password to something completely different. All right? They're not going to be linked. Once you change one password, it doesn't change the other. But the username is going to be the same. And the default password currently is the same as well. Okay? So just keep that in mind. So we'll get on both today. So let's get on our class website. Please, everybody, if you haven't figured it out, you have buttons to bring up computers, these up arrows. Hold those in, please. And then copy up by the monitor. You have your mouse and your keyboard as well. You just bring them out. So please, everybody, go to www.lawtonsclass.com. Another way to get there is there's a link on our Canvas homepage down here at the class website. All right? Either way, get to this page, please, and log in. You all have accounts. You should all have accounts. And your username and your password right now are your last name, lowercase, no spaces, no hyphens, an underscore, and your student ID. So if your last name is this, and this is your student ID, your username and your password right now is this on the class website. If this is your last name and this is your student ID, then this is your username and password on the class website, okay? So that's how that works. No spaces, no hyphens, no accent marks, just all like that. And let me know if it's not working for you. We're going to go to the attendance app, and that's how we'll take attendance. Yes? You can call me Lawton. You can use whatever you like as long as you can get to this website. This is how we're going to do it. Okay. So just let me know if you can't log in, because this is how we're taking attendance, and if you don't get marked here, you get dropped. You need to go to that place somehow. All right. Is there anybody having trouble logging in? All right. So this is what we'll do at the start of class from now on. Yeah, I should say right now, those of you who are not on the wait list and not currently enrolled in the class, I'm not letting you in. Okay, so if you're here, I'm sorry, but it's not worth it. I'll only let in students that are currently on the wait list. So, all right, take attendance. This is us. Begin attendance. So now you can click a button and it'll work. It doesn't matter which one you click. But all right, let's make sure everybody is able to do this. Is anybody having any issues at all? Okay, so once you click a button, to make sure that you're not going to get dropped if you're as anxious as I am, you can go to view my attendance after that, and you should see that you were marked here. Okay? Now we'll make sure that everything is good. Is there anybody who has not yet marked themselves? One click a button. right, everybody. Has anybody not clicked a button and marked themselves here? Alright, speak now if you have not marked yourself here and you are enrolled in the class. I'm about to stop this attendance. We need to move on. Just leave it running then. We gotta move on now though. So yeah, if by the time the lecture is over you have not marked yourself here, you need to talk to me because I have to drop you if you don't have your attendance here. Okay? So I'll just leave this running for now if we're having issues, but I think I'd like to move on now. Alright? So let's actually have a lecture. Alright? This is what we're gonna do at the start of class from now on. Okay? So I guess actually Declan, do you want to introduce yourself? I think this is a good time. Yeah, before we get to lecture, I'd like to introduce you guys, and have him introduce himself, actually. Declan, who is going to be our embedded tutor for the class. Okay, you're going to love him.
Was going to be it. Oh, I got replaced already. What's up, everyone? My name's Declan. I see a couple familiar faces. I am going to be your embedded tutor for this class and for the rest of the semester. I currently work as a STEM tutor over at the Tutorial Center in AC1. I've been doing that for about 2 years now, and I've been embedding for CSCI 40 type classes for about a year as well. There's a lot of people on here.
Yeah, there are.
I think the cap was supposed to be something like 48.
Plus a few people on the wait list hanging
A
out.
few people, is something like 72 of you in here. Well, I mean, hopefully we can keep all of you in here, because this class is really, really good to learn, whether you're doing it just for core classes or whether you're actually going down the computer science route. I'm really looking forward to working with all of you, seeing what you guys can do, and I know that Professor Lawton is a great professor, so I look forward to a good year with y'all. Yeah.
Yeah, do you want to explain the tutorial center or anything?
Sure. So the Tutorial Center is a free resource for any students on campus. It is over in AC1 141, right near where the Open Computer Lab is. You can go in there if you need help with any of your subjects, whether it's humanities or STEM-based. I personally work in there as a mathematics and computer science tutor, but we have tutors in there who can work on virtually any subject you want. So if you need any help with any subject whatsoever at any time of the year, we are open from 9 to 9 Tuesday through Thursday, and 9 to 6 Monday, 9 to 5 Friday. So we got your back pretty much any time of the day that we can get to you. And yeah, so that's AC1 141 if you guys need any help.
Definitely take advantage of it. It's the best thing ever. Thank you, sir. All right, I think we're good. So again, let me know if you can't sign in. I'll keep it running for now, but I want to make sure we're all here and not getting dropped, all right? At the end, at least. So I think we're ready for having a real lecture. Let's do it. So I'd like to teach you a little bit about computers, I guess, and then also about C++, which will be the language that we're going to learn in this class, okay? I'm going to give you a lot of information today just because you need to have heard it once, and then you can always come back and reference this stuff, okay? But you need to hear all these terms once, even if they're confusing, and it'll make sense eventually, I promise. Just keep on coming back here. You can try out all the code that I write today. I'll show you how. I'll get you on the class server where you can write and make your code work. That's a great way to study because I'm going to give you all this stuff, okay? So yeah, here's what we're doing today. Before we get started with like real content, I want you guys to like meet each other, or like let's figure out the makeup of the class, because something that I like to do is on our class website, there's many other apps, and one of them is called ByClicker, which is a parody of this thing called an iClicker, which maybe you guys have seen before. If you take like a giant physics class or something, you like have to buy this $70 remote control to press A through E with, and I think that's dumb. So I've made a free version of that for us in this class. Okay, so that's the goal, and I will often split you guys up into little groups with people sitting next to you, And we call that peer instruction, where you guys can help each other rather than listen to me all day. And all the literature says that that's the best way for you guys to learn. You learn so much better teaching each other rather than listening to me drone on. Okay, so I promise it's worth it. It's going to be great. Our first question for this bike clicker thing is on the next slide. It'll just be an individual question to start out. But yeah, it's an in-class exercise, which people abbreviate as ICE. And our mascot here at Clovis is a bull named Crush, and I have no clue why those two things go together at all. It's also a blue bull. So if anybody knows the origin story, please tell me. But obviously, that means our in-class exercises will be called crushed ices. So please go to the bike clicker page. I'm gonna go to it on my admin end and start the question. But let's get a feel for who's in the class. Please tell me your major. So one of these: computer science, computer engineering, some other kind of engineering. Are you like a math major, some kind of STEM, or something completely different? Just trying it out. Question? Still gotta learn how to program. So yeah, hopefully we're all there. I'll just give you a few seconds to get your information in there. But let's see who's in the class. Okay? Let's figure this out. So, sorry if there's any bugs on this website. I rewrote it over the summer just to get practice. We'll see. We'll see if it's happy enough. Looks like it's working. So a lot of us are computer science majors. That makes sense. Welcome. It's probably your first computer science class. This is great to have you. But we have people all over the spectrum, which is great, which is really, really good. Few people, like 2 maybe, 5 who chose C, some other kind of engineering. We got STEM, we got non-STEM even, humanities. So yeah, the class is a better place because of your varied perspectives. It's great. Yeah. Yeah. No, it's all good. So that's the first one. We know a little bit about ourselves now. And then, all right, here's the next question. Same page. So we're going to do a lot of work in a magical place called the Linux terminal. Have any of you used that before? I don't expect you to have, but you tell me. Tell me if you've never seen it, never even heard of it. A Unix terminal as well, like Macs have terminals, for example. That counts. Have you used that before? I honestly don't even know if I would pick E. There's so much to learn still. Plenty of little terminal commands that I don't know enough about. Mm-hmm.
If you picked an answer, could you click another one and change it?
Yes, I will change your answer. All right, yeah, bless you. Here we go. That's a nice little tail distribution there. So, okay, a lot of us pick an A, which is great. This is a good spot for you. I will teach you everything you need to know. Might be a little fast, but you'll get plenty of practice, all right? And those of you who picked B and C, help the people who picked A, all right? We're all here for each other. All right, one last question. We're going to learn a language called C++ in this class. Have you ever used it? Again, don't expect you to. This is your first programming class for most of us. So let me know.
The question changes something across the page or
Just click again. In the class, what you guys know, just like we're introducing ourselves virtually kind of right now. It's not fun. We got an extra person this time. Nice. So good. Most of us are picking A. That makes sense. But again, people who chose B and C help the people who picked A. You're going to be at an advantage at the start of the class for sure. All right. So thank you for putting up with me for that. Let's get into a real lecture now. I'll give you some time to work with each other later, I think, too. So let's talk about computers. Let's talk about programming. Let's make it happen. So first thing I want to say is what is a program just generically? A program is just a recipe, honestly. If any of you have cooked before and modified a recipe, you've been a programmer. Okay? So it's not something that's difficult. I promise. I'm going to make it as easy as possible in this class. And every program is made up of one or more little sequences of steps called algorithms. Those are just little recipes in a bigger recipe. That's all it is. All right? So I would like to show you guys how easy it is to program. I'll ask you a seemingly innocuous question. Let's say that I fell and hit my head, or I'm an alien visiting Earth or something, and you want to tell me the like you want to tell me about the delicacies that exist in American cuisine, what would you say to somebody who's never heard of a peanut butter and jelly sandwich? How would you tell someone to make one? What's the recipe? Can somebody tell me how to make a peanut butter and jelly sandwich? Somebody be a programmer for a second. Just shout it out. Yeah. Nice, nice. I like the specificity there. I kind of know where I'm going with this. But I think if I were in this class, probably what's in your head right now is just like, all right, get some peanut butter and get some jelly, put it on some bread. Bam. So I'm going to pretend that I'm a computer running your program to make a peanut butter and jelly sandwich, okay? I'm going somewhere with this, I promise. So you're like, you're right. You're going to say, okay, to make peanut butter and jelly, get some peanut butter, get some jelly, and put it on bread. I'm like, all right, as a computer, here's what I would do. Like, okay, here is a bag of bread, my best three-dimensional drawing of the day. It's a bag. Whee! Doop, doop. And then there's the little slices inside the bag. There's my bread. And you're like, okay, take the bread and then put peanut butter on the bread. Okay, so I, as a computer, would be like, okay, here's the peanut butter jar. I will stick that right on top of the bread bag. And then you're like, okay, get some jelly too, put it on the bread. Here's the little jelly jar. I'll put that on the bread too. Voila! I've just made you peanut butter and jelly. I followed your instructions. I ran your program. Ta-da! That's what you wanted, right? I don't think so. Unless we're really weird. We like to eat glass. So, yeah, exactly. Extra fiber. Maybe not. This is a problem, right? This is how computers work. You have to be very specific when you're talking to a computer. This is where I'm going with this. You have to talk down to a computer, essentially. Okay? You have to talk to it in a way that it understands that's unambiguous, which is very low level, lower than maybe you think about right now. Okay? So I'm going to teach you how to think like a computer. All right? That's my goal for this class. I'm going to teach you how to think in terms of those little basic operations that the computer knows how to work with and perform. And that's going to involve, like, I have this big problem that I'm working on. How do I break it down into little chunks that I understand how to explain to the computer? That's going to be the goal for this class, hands down. All right? And there's also a concept of sequentiality. Like, I have to do this before this. I have to, like, get the bread out before I spread the peanut butter on it. So that's going to be my goal, to teach you how to program, teaching you to think like a computer, okay? And how to talk to it in the right way. So, yeah, the correct, maybe, algorithm for making a peanut butter and jelly sandwich, the correct recipe for the computer would be like, all right, get the bag of bread, get a plate out, go and take 2 slices of bread from the bag of bread, put them face down. Go get a knife from the drawer, open the peanut butter jar, take the knife in one hand, stick it into the peanut butter jar, get some peanut butter on that knife, and spread the knife on one of the pieces of bread. Do the same for the jelly. And then shove them together where the peanut butter touches the jelly, because you can totally do it the other way too, right? You have to be specific. So that's more like what we're going to do in this class. I hope that makes sense. Okay? You all can do it. And here's just a fun little meme that kind of goes along with the same ideas. Like, you have to be specific when you're talking to a computer. There's a right way to do it, and it is a little tedious at first, learning the language, but we'll get there. Okay? So that's the goal. Any questions about any of that? All right. So, yeah, we're going to learn a bunch of cool stuff this semester, a lot of stuff, just foundational stuff, a lot of terms that will be defined again and again. So, like algorithms, we'll talk about those more. Those are just recipes, right, for making stuff. We'll learn a lot about testing towards the middle of the class, and that's just like, all right, how do we make sure our program is correct? Well, in terms of the peanut butter and jelly, we should go and eat that peanut butter and jelly and see if it tastes good, because maybe we did it wrong. That's what testing is all about. There's going to be a concept of, like, implicit things that are assumed when I'm giving you a problem that you just have to understand, right? Not part of the problem statement itself, but, like, it's somewhere in the solution. You have to figure it out. All right, so that's important. Like, what assumptions are involved in this problem? And just a silly example of that is like, all right, if you go and it's your birthday and you want to light a birthday candle, like, you're not going to ever sue the manufacturer if you try to light that candle underwater and it doesn't work, right? That's an incorrect assumption on your part. Okay, there's going to be similar things in terms of programming. All right, and then finally, computational thinking. That is when you think sequentially, clearly at the right level. And that is the goal of this class. I will make a little rainbow star right there. That's where we're going. All right. That's going to be the backbone of everything. I hope that makes enough sense. Okay, so that's what's happening. And yeah, let's talk about computers for a second. This is like a basic definition of a computer. What are all the pieces of a computer? You got like things that give input, sending data into a computer. How can you do that? Type it on a keyboard, moving a mouse, tapping your screen on your phone. Those are input devices. Output devices are how you get information from a computer, how it shoves data out into you somehow. So that's like the display on your computer. A printer even is an output device, technically. We're going to learn how to talk to the actual CPU, the processor itself, though. You'll learn more and more as you take more CSCI classes. But yeah, the processor is the brain. That's where all the thinking happens, where all the computation, like the additions in your program happen. Takes place there. That's where your program gets executed. And if you've never heard that term before, it's not like somebody's murdering your program. It means it's running. Okay, that's a synonym for running a program, executing it. Okay, and then the CPU is talking back and forth with the memory of your computer, the main memory or the RAM, random access memory. That's where information is being stored. That's where where the long-term memory of your computer is, essentially. It's storing information about the current running programs, and like every time you run a program, it's getting copied into RAM so that it can run, and it's faster to access that way. And so like all the programs that are running on my computer right now, taking up memory, they're somewhere in RAM. That's why if you want to run a bunch of programs at once or have a bunch of tabs open, then you need to install more memory on your computer. Okay, so there's also secondary memory, which is farther away from the CPU, slower to access, but you can hold more stuff. That's like your hard drives that spin, or SSDs, or even flash drives. Those hold a bunch of things, but it takes a while to get information out of that. That's why we put it in the main memory as we run our programs. Okay, so just terms maybe you've heard of, maybe you haven't. And then we're going to talk about C++ a lot in this class. Okay, so that's going to be the language that we learn. It is a language that was invented back in the mid-'80s, so it's been around for a little while. It's older than me, older than most of you probably. And it was based on an earlier language called C. And there's a joke here that either I'll teach you today or next time. And so it's like better than C, kind of. And it is what's called a high-level language, which means it looks a whole lot more like English than it looks like the ones and zeros that actually need to run on a computer, which is good for us. Okay, but because it looks like English, you can't shove that English-looking program into the computer and have it run yet. It needs to be converted into those ones and zeros that the computer understands. It's like you write your program that looks like an essay or something like the blah blah blah, and then you send it to something called a compiler. So C++ is a compiled language. Compiler, little black box that takes your program and converts it to binary, to the ones and zeros that your particular operating system and CPU architecture can understand. Okay, and that is runnable, copyable into RAM, and it all works. Okay, so that's the idea. And I'd like to show you now the simplest complete C++ program. All right, the simplest complete C++ program is a program that does absolutely nothing at all. It just runs and immediately stops running. Okay, so it's going to be useless, but it's a good first taste of things. So here's a new file. I'll call it donothing.cpp. That's the standard extension for C++ programs. I have to say int main, open paren, close paren, two curly braces, and in between the curly braces, I say return 0 semicolon. I will explain this later. All right. So to compile the program, like I have it here now, I have an extra file as well that I'll show you later, donothing.cpp. I'll use a program called G++, donothing.cpp, give it that. It's made a new file called a.out, and to run it, I say /a.out, and I hit enter, and it will run the program, and the program immediately stopped running and gave me a new terminal prompt, and I can run it as many times as I want. It does nothing at all, produces no output. That is our first C++ program. Okay, I'll explain it more later. So that's the idea. That's where we're going. Now that I showed you this is called the terminal, by the way. This is my editor. This down here, this is a terminal where it's giving me a prompt and I can type commands. And some commands exist, some don't. And you hit enter and it will run those things. Okay. So let me teach you about some useful terminal commands. Here's like a blank terminal. Let me go to what you'll be using. This is kind of what your terminal is going to look like. Something like this. Username, blah, 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 and a little tilde. What the tilde means is It's short for your home folder. It's a special place that's just for your account. I've made you all accounts on our class server. This tilde is shorthand for your home folder, okay? If you want to see what's in your home folder, you'll type ls, short for list. List the contents of my current directory. There's always a concept of what folder am I in right now? Like, for example, on my file browser, like I'm in my CSCI 40 folder. If I double click, now I'm in a different folder. Same thing happens on the terminal. I'm in this current home folder right now. I've got a bunch of little files here right now. The full name for my current directory I can get with pwd. That stands for print working directory. Directory just stands for folder. And so apparently I am here in the root directory. There is a folder called home, and inside of that folder there's a folder with my username. Okay? And so that's where I am. That's what tilde is always short for. It's always short for your particular home folder. All right, ls shows you what's there. I got these files right now. Some are folders, some are actual files. If I want to move around, like I want to double click and go and work inside of this folder with these files here and look at them, you say cd. That stands for change directories. You're going to be coming back to this slide a whole lot, okay? Cd, and then you give the name of the folder. You hit enter, and it goes into that folder for you. So let's all right, there's a bunch of places here, pwd. There's like an outermost folder, cd/, it's like the outermost directory. pwd, there's nothing there. That's where you are. What's there? ls, all these things. All right, and then, okay, there's a home folder. That's where my home folder was, cd home, ls. And then there's a bunch of folders for every user on the system. There's just 2 right now for my personal computer. cd back here, and now I'm back in my home folder. If I'm ever lost, I can always say cd tilde to get back to my home folder. So you'll be using that a lot, right? That's important. If I ever want to go back out to where I was before, like I make a folder and I want to go back out to where I was previous to that, ... is always shorthand for your parent directory, one up from you, okay? So like if I'm currently in my home folder, which is home lot, if I want to go back out to just home, cd ... takes me there. It goes up 1, okay? That's useful. It's always your parent directory. And then to compile a program, we say G++. G++ space, name of the program, hit enter. It'll make, if there's no errors at least, it'll make a new file called a.out in your current directory. So if I go back to my, the folder that I was working in here is this long thing, lecture 1 folder. By ls here, a.out exists now because I compiled. And you say / to run that program. / name of the file, hit enter. No spaces with that one, okay? And what dot means is it's shorthand for your current directory. So it's like, all right, run the thing in my current directory called this. That's kind of how it works, called a.out, all right? So you're going to be coming back to this slide a lot. I'll give you the PDF soon. Don't worry about it. But that is what you're going to need to move around on the terminal. Okay. Questions?
Where will you give us the PDF on Canvas?
Yes. Everything will be given to you on Canvas. All right. Let's see. Next, we have to talk about editing code because I have to write the files before I compile and run them. So here I am using an editor called Vim. There are plenty other editors in the C. So an editor is just a program that you use to edit files. Like Microsoft Word is an editor. Google Docs is an editor. Okay. They can be either terminal-based or graphical. Like Word is graphical. Vim is terminal-based. To start out, I'm going to teach you an editor called Nano. That's like the easiest one possible. All right. It's not great for programming, but it's good to start with at least. So if I say, it kind of works like I was doing here. If I say nano space, the name of the file I want to work on, it takes me to a place where I can move around with my arrow keys and start typing and change things. And then to save, it's Control X to save and exit. Like Y, yes, I want to save it. Hit enter to keep the same name. Now I'm back and it's been changed. Stuff like that. So that's how I'm going to teach you at the start during the lab time today. And then next, we have Vim, which I'd like you to eventually learn. Right? It's another terminal-based editor. All the cool kids like to use it. It's better for programming for sure, but you have to do a Vim tutorial before you use it. All right, I'm going to force you to do a little tutorial because the meme is nobody knows how to quit out of Vim, and you will soon experience that if you try it. So do the tutorial first. There's also graphical editors. Visual Studio Code is probably the most popular one, I would say, among especially students. And if you want to work on your own computer, I'll get you set up with that one probably. I'll help you there. Okay, so that's just a new word, editors. And then I should also kind of motivate, like, why are we learning C++? Why not Python? Why not some other language? So I guess the short answer is because that's what Fresno State teaches, what a lot of other schools want to see. But a better answer would be it's on the lower side of high-level languages. So yes, it looks like English, but it's also very close to the CPU and what the CPU knows how to do, if that makes any sense at all. And because it's so close-ish, it's faster. So it's a language that a lot of people look to when they want to write code that needs to be run quickly. Like all of your, like every Adobe product written in C++. Every web browser, the engine underlying the web browser that's rendering every page that you go to, running in C++. All right, compiled C++. Most video game engines need to be fast, run as fast as possible so you can get the best frame rate, right? Written in C++. So hopefully it's worth learning to you. Okay, let's zoom in a little bit more on that compiler thing. It's a little weird. So we had our do-nothing.cpp, right? We started with a C++ program, do-nothing.cpp. And then we shoved it into the compiler, which was our G++. And what a compiler's job is, the lines get a little bit blurred with G++ because it does a bunch of things at once. But really, if you want to be very specific and pedantic, what a compiler does, its job is to take a single program file that you've written, one .cpp file, and create what's called machine code or object code out of that. That's ones and zeros for that particular program only. So it's like those files end in .o. We didn't see it because G++ like removed it immediately for us. It was doing it all for us. But eventually, it'll be useful to understand. And then, again, G++ did something else. It's doing things quickly for us, which is unfortunate. But in addition to the compiler, there's something called a linker, which takes a bunch of other things that have already been pre-compiled for you. Like eventually, we're going to use stuff out of something called IOStream, specifically something called standard : cout. Looks a little disgusting, I know. That's going to let us print stuff to the screen. And like, we don't want to program how to print to the screen in Linux. That's been done for us. We get to use that code already. That's been made, okay? And then G++ will link that too. And so sadly, G++ does both, and so it's kind of hard to see the difference. But the linker is a separate place, all right? And we like to link our programs with things that have been pre-made for us. Those pre-made things are called libraries. It's a fun little metaphor. You can like go to the library, get something that's all, like read a book that's already been made. Go look at their recipes, okay? A library is just pre-implemented code for us, so we don't have to reinvent that wheel. And yeah, after both of those processes are finished, you have a working machine code program that you can go and run. This spits out an a.out file that you can then go and run with a /, right? a.out. I hope that makes at least a little bit of sense. Good enough for now? I'll show you how to do this all later yourself. But yeah, I think let's actually learn C++ and write some C++ programs, okay? Make it happen. So they will take my computer science card away if I don't give you one program first. It's called a Hello World program, all right? It's customary, as you're first learning a language, to write a program that prints to the screen. All it does is print to the screen and say, hello world, as if it were sentient, something like that. That's like you showing that you can have the programming language do what you want, do your bidding, okay? So let me write that program, and then I'll explain it to you, okay? So, make a new file. Hello.cpp is what I'll call it. And I'm going to type right now, and I'll explain it later. Include angle brackets, IOStream, int main, curly braces, got that return 0 still, and then I'll say standard : cout, 2 less than signs, in quotes, hello, comma space world, exclamation point, semicolon. That's it. Save the file. So, let me, for a second, I need to go to this so I can show you something. It's a little disgusting, and I'm sorry. And now I'll stay here for just a second more. But that's the file itself, all right? And now let me explain it, kind of. So first of all, I would like to explain in the code itself. There's a way to leave little notes for yourself as a programmer. It's called a comment, all right? If you use 2 slashes, everything after those 2 slashes is called a comment, and it's not interpreted as code. You can write whatever you want, right? Write a novel there if you want to. Right? So this is a single line comment, all right? I'll put that in quotes. Why not? So it's meant for programmers only. It's not code. It's not being translated into code. If you want more single line comments, you got to put 2 slashes on that line as well. It's not code. So you can write whatever you want and misspell it all you want. It's not, the compiler is not looking at it, all right? If you want to write a lot of stuff that take up multiple lines, this is called a multi-line comment, where you don't have to keep doing the same thing. You can do /* and then end it with */. So here is /*. This is and I'll make new lines, multi-line comment, and then I'll end it off with */. It's another way to write notes for yourself. Okay. So now with that, I can explain what all this stuff is doing. So what does include with a number sign O string? That is a library file. It's a library file that I'm having imported into my program so I can use the stuff from that library. Okay. That gives me access to a few things, one of which, the one that I use right now, this gives us access to standard : cout, which is great. There's that. And then, all right, what's the rest of this? So what's int main, all these brackets and things? What's going on there? All right. This is called the main function. This is called the main function. It's where the program starts. All right, so that's very important. And everything between the curly braces are the lines of code that are getting run as the program is happening. Okay, so all right, what is cout? Standard : cout is shorthand for it's the terminal screen. All right, so that's what that's doing. And then I am taking something in quotes and shoving it into cout. This is meant to be interpreted as arrows. So taking this and shoving it into the terminal screen. Okay, that's the goal there. And so stuff between quotes, by the way, things between double quotes are called strings, like a string of beads on the friendship bracelet that you took to the Taylor Swift concert. Yes. No spaces are necessary in C++, but I'm going to try and make it look pretty for you guys. Any other questions? Good question. All right. And then semicolons are like the end of your sentences in C++. They end your thoughts. That's the end of that statement. All right. Print that and then new thought. Period. Semicolon. Right. Like the period of computer science. And then return 0. That marks the end of the program itself. It tells whoever was running the program, which is the terminal for us in this class, tells the terminal that your program ended or executed successfully. All right, so 0 is a code that means success. Anything other than 0 means some form of issue happened as your program ran, but we ran it successfully. We got here, got to the 0. The terminal sees the 0 and it's like, okay, cool, everything worked out. All right, so that's that. And then just for posterity's sake, I should talk about that semicolon. So semicolon marks the end of a C++ statement, right? It's like one full thought, right? It's the equivalent of the period in English, of the English period. Okay, so here's the full program, if I can show it to you. And then I'll compile and run it. Question first?
With the function for the slash, double star and then slash, can you write that in the same line as your comments?
Yes, actually. So I could write a note on the same line. It's always I could usually use single line comments, but comment. So is that what you're asking? Can you do both?
Scroll up to line 6.
Yes.
Can you write the star slash right next to comment? Will it
Yes.
end there?
Yes. Wherever you put that is where that ends. Yes, exactly. You can put it wherever you like. Yeah. Good. Any other questions? Let's watch it work. Yeah. Let's do it. So let me go G++. I have it out right now. It's from the old program. G++ hello.cpp. Hit enter. It overwrote the edit out file. It's still there. And now I'm going to run it in a different terminal for a reason. /a.out. Hit enter. And it prints hello world. Look at it. And then it gives me a terminal prompt on the same line, and that is ugly. So we need to fix that. Okay. it would be nice if it pressed enter right here and gave me a new line after it ended on the next line. Does that make sense? That's what I would prefer. So let's fix that. So that we can fix with a \n, all right, in our string. If I put a \n here, this, it's not going to print a \n and an n. This is called an escape character, all right? It's a special character. When, as part of a string, C++ sees it, it will be interpreted as something completely different. So if you do \n, it is short for pressing enter. It makes a new line. Okay, that's the only way you can do that. You have other escape characters. You have \t, types in the tab for you. \r does something cool that I encourage you to play around with. And then that means, though, you can't type an actual backslash because it's waiting to see what the next character is to do something secret. So if you actually want to print a backslash, you have to do \\. Two become one, if that makes sense. But this \n will turn into enter. And so now if I recompile this, with G++, rerun it again, ./a.out, you see that I now get a new terminal prompt cleanly on the next line because it pressed enter after the exclamation point. Does that make sense? That's cool. That's what we like. All right. There is also a shorthand for \n. It's more typing, but sometimes it's a shorthand depending on what you're doing. Standard : end L is also an IO stream. So this gives us access to standard : cout and standard : end L. And so instead of this one, \n, you can also shove multiple things at once. You need multiple arrows to do it. Shove also standard : end L into the terminal screen. Right? So shove that data there, and then also that data. I'm going to separate things with those arrows. And so that'll do the exact same thing. No difference. So re-G++ it, re-a.out. It's still pressing new line for us, pressing enter on the terminal. Stands for end the line. Okay. There's that. If we're still good. This is getting a little bit ugly. Wouldn't it be nice, like there's a lot of typing, wouldn't it be nice if we didn't have to put the standard : all over the place? Like, that'd be nice. Like just type cout, just type end L. That's possible. There's a way to do it and skip that always by doing this line, by saying, all right, just go and look in standard : if you don't already see it. It's probably there. So using namespace standard, I would like to use something called a namespace, and I'd like to use the standard one from the standard library. All right? So this lets me now I can skip the standard : all over the place. So standard : cout becomes just cout. Standard : end L becomes just end L, and that's better. You can imagine that you're going to print a lot as you're writing programs, so this helps you save typing. So that's useful. Recompile, rerun. Same output. Cool. So there's that. Yeah, we have those strings. We have those escape characters. I think that's what I want to say for that program. Let's also write another one now. Let's do a program that does math for us. Okay. Again, I'm going to give you all this. Let's do a program that calculates the area of a circle with radius 5, because this is why computers were invented, right? They do math for us. Let's write a new program and make a new file called area.cpp, and we'll use our knowledge now. So include iostream for cout and end L, using namespace standard, so that I don't have to type standard : over the place. Start the main function. The last thing of every program should be a statement that says return 0 to tell the terminal I'm done now, and everything was a success. And now let's say, all right, we have a circle of radius 5. I'd like to print out the area of that circle. What's the formula for the area of a circle, guys? R squared. So I like to shove into the terminal the result of pi, 3.14, multiplication in C++ is a star, and the radius is 5. 5 squared, just multiply by 5 twice, yeah. So there, do the math for me, C++, and end it with a new line, because we're cool like that. So now, G++ area.cpp overwrites a.out, /it, run it. Apparently the answer is 78.5 with this precision of pi. Okay, that's not bad, right? Little mini calculator for us. Any questions about this program? Yeah.
Can you do a \n?
Absolutely, but you have to put it between quotes. So that's actually why it saves typing, because now it's the same number of things and there's less shifts to press when you're outputting just numbers, because you weren't already in a string. If you're already in a string, it saves you type and just do the backslash in. Great question. All right. Last thing I want to say is that C++, very, very liberal, does not care about your white space. So like nothing, except for like this probably, you don't have to put spaces pretty much anywhere. And then you don't have to break the line at all ever if you don't want to after the include. So this could be the program. And I could do that. I could do all these things. Like none of these spaces, a lot of these don't need to be here. But this is disgusting. I hope you agree. You could write your programs like this, and Nano lets you. So you should learn Vim, and it will help you keep things nice. I'll do my best to give you good style. Okay. So here is how I'll write it, I guess. There. It'll still work though. All right. So yeah, we've come far. We just wrote some really cool programs in C++. We give yourself a pat on the back if you understood any of that, because this is your first foray into programming probably. Good job. You're super cool. All right. So if we are happy, let us do a few more things, and then we'll have our break. So first thing I want to say, let's talk about variables. Let's talk about storing things for later. All right. So a variable in code is just a little box. Think of it like a box in memory. Right. So I can make a line that says this: int x equals 42. And what that line does is it makes a box in memory called x, and it has it hold 42 for later. So now I can say x instead of typing 42 all over the place. All right. So let me show that to you in a new file. And yeah, there's a bunch of different things that you can put here. I had to say int x, not just x equals 42, int x equals 42. Because C++ really cares about what kind of thing you're going to put in that box. It cares about the type of your variable. Right? These are called variables that we're making here. So here are some types that I want you to know right now. Int is the first one. Those are for whole numbers. All right. So I used the pizza metaphor if you want to read that. But I want you to think of types like a cloud. Like what could go in the int type? 0 could go in the int type. 8 could go there. 42 could go there. Whole numbers only. Could be negative. Negative 42, that's fine. That's the kind of things ints hold. All right. If you need decimal places, double is your answer. All right. So the double type is a cloud. That's much bigger than int because it holds whole numbers too. It's like 0.0 though. So it holds like 12 as well, but it's like 12.0. And it also holds anything with decimal, 3.14. It has scientific notation as a possibility as well. It's like anytime you need decimals, double is your type. Ints cannot hold anything with decimals. If you want to hold characters, like things you want to print, to hold a single character, there's a type called char. Some people pronounce it as char. I'm just going to read it as char. That's how I learned it. Doesn't matter though. So the char type, what does it hold? It holds single characters, and those go between single quotes, like capital A character, the space character. Just single things, though, between single quotes. That'll help you remember. And then if you want to save in a variable for later, place for later, full sentences, all right, then you use what's called a string type. I told you that already, right? So a string is the type of things with double quotes that stores just any text at all. So hello, as long as you want it to be. Capital the, as many spaces, and as many new lines as you want. You could have the string 300, though. You could have strings that have digits in them, but it's not a number. Does that make sense? It's a different type. We'll think about that, all right? That'll be important later. So let's make some programs that, let's make one program that does that has that in mind. So I'll make a file called vars.cpp. Let's start out with all this stuff, include iostream, using namespace, standard, int main, return 0, boop. And then, all right, what do we want to do? Let's make some variables. Int x equals 42. That makes a box called x that holds 42 for later. And now I can say x. See out x, please, in a new line. Does that make sense? Now it'll print the 42 out as you would expect. There it goes, 42. Is there anything else I want to show you? Yeah, not yet. Let's make some more variables with some more names. Let's make one that is a double. Question?
We're supposed to be like actually like typing out the code yet, right?
do whatever you want, but I'm going to give you all this.
Like, are we just like watching you do it, or is it do it, or is it do it too?
I can't answer that because it's up to you. Whatever you want to do, you can do.
Like, how would we do it if we wanted to?
You could, I'll have to show you how to get on the terminal and type out your code. I think you'll have to wait for that at least. After today, though, you could be doing that. Yeah. Let's see. Let's make a double variable. So instead of int x, it'll be like double, can't be x anymore because we've used x. Double d equals 3.14. See out variable called d. Cool. There's a new line. Oops. Save. 3.14. Cool. I think you get the idea now. Single characters, single quotes. So char, make a variable called c, have it hold single quotes c, semicolon always. Capital C for CSCI. See out the lowercase c variable. Print it out. There's that one. And actually, to have string variables, surprisingly, you have to use, there's a library for that. You can use double quotes all you want, but to have something called string, have the type string available to you, you have to include a library called string. All right. Have to include the string library to use the string type. If you want to make a variable that's a string, you got to include the string library. So now I can say string s or whatever I want to call it equals double quotes, hello. And now I can see out whatever's in s. So I hope you see how that'll save your life later. Put stuff, use it multiple times, move it around. Yeah. Say that again? We'll get there. It is an object, technically, yes. In C++ too. Yes.
So is anything imported from like a library not turned down like
Yes, the editor is doing that for me. It knows what's baked into the language. Yeah, because it's not baked into the language. It's part of a library. Exactly. Yeah, that's one way to think about it for sure. Very astute. So yeah, I hope this makes enough sense. Obviously, a program isn't a program. It's not very useful to write a program that just spits out stuff because like you could just like type it up, right? Make a Word document. Where programming shines is to get input and have that input influence the output. That's the whole goal of writing programs, all right? So there's a counterpart to cout called cin, which shoves information into a variable, okay? So let me show that to you. Cin, let's make a new file. cin.cpp, include all that boilerplate stuff, lightning speed. Let me ask the user for a number this time. I'll say cout enter an int, please, Mr. User. And I'm not going to break the line for a reason I'll show you, right? And then I need to make space for an integer that the user will eventually give me. I need to make the box in memory, but I don't have anything to give to it yet because I want the user to give me something to put in there. So you can say this. Instead of int x equals 42 or whatever, you can just say int x semicolon, and that makes a blank variable for yourself, right? So x holds nothing at all right now. X holds nothing right now. And I'll eventually fill it, right? I'll fill it with whatever the user types. That's my goal, okay? So int x, it's completely empty right now. Holds question mark, yes. You have to give its type, yes. So just like I was doing for all these other guys, if it's a whole number, because this variable will eventually hold a whole number, it's got to be an int. If you need that variable to hold something else, it needed to be a different type. Yeah, okay? Good. So we've got room for it only now. Doesn't exist. Doesn't have a real value yet though. And all right, we'll say, hey, enter an int user, and then I'll say cin, and then I need to give some arrows, and I'd like to give information and have it be filled into x. Which direction is information flowing for this line? Which kind of arrow do I need? If this is the user's keyboard, and this is the variable I want to fill, which arrow do I need? I'm shoving information this way, into x. Does that make sense? Good. So, that's the arrow I need for cin. Opposite. Question? Yes, because this takes the string. This is the direction of data. I'm giving information to cout. No, I have to say, yeah, you have to start it with cin. Yeah. No, in some languages you could do that, but no, it has to start with CN or CF because that's the library thing. That's how it works. Yeah, that's a question I can't answer too well right now because we don't know enough, but that's a great thing to think about. Yeah, it has to start with CN. So after this line is completed, like it'll stop the program and ask me to type as the user. And then I'll type my number and hit enter, and then X will have been filled. And then we can see whatever is in there. We'll see out you typed space, whatever was in X, and then a new line. Won't that be cool? So G++ CN, that's CVP, /CN. So here is why I didn't break the line after enter and int. Watch. Oh, sorry. /a.out. Look how cool this is. It gives me a little prompt on the same line. That's kind of how you wanted it. That's why I had the space too. So now I can type like 42, hit enter, and it shoved 42 into X. And then that's what it showed to me. And now the program, this is the beautiful thing about programming, I can rerun it and type something different, and something different happens. That is why programming is cool. Hopefully you agree. So that's the goal there. And yeah, you can do that for any type. If you would like the user to type in a character, you got to make an empty character slot. Is there a question? Okay. Yeah, so now we can do kind of the same thing. Just like, all right, enter a char this time. Oops. Enter a char. Feed into C now, and then we can see what the user typed. Or if we want them to type, have them type a double, right? Let's see. I'll save this for later, actually. Have them type a character, have them type a double, call it D, read into D. Now I got a bunch of variables filled with stuff from the user, and I can output those. See out C, see out D. So now if I run this, in addition to getting an int, oops, G++, /a.out, 42, capital A, 3414. Cool. And it's kind of, oh, sorry, I need to give this a different type. It's double. You see that it worked, and it gave me a 3, which is a weird quirk of C++. Sorry, 42A, 3414. There. So types are important. Are we following this? Does it make enough sense? Good. Yeah, it's okay if it's not fully there, but as long as you're getting a little bit of it, that's what I care about. It's the first day after all. So yeah, you guys are doing great. So I'd like to just make sure we're still awake. Please go back to the ByClicker page. And feel free to, let's see, interact with the people around you this time. Like, go look to the left, look to the right, introduce yourself, and see if you all can agree on the answer for this one, right? But I'll give you like a minute to say hi, talk about your summer, and then enter a new answer and come back. What does a compiler do? Which of these? And I think this is a great time to check. Has everybody been able to sign in for attendance now? Can I stop that? Or none of us are going to get marked absent and dropped? Shout out right now if I can't stop attendance. We're good? Awesome. I'll be stopping that later. Oh, nice, yeah. No, yeah, I can imagine. You just have a class.
Get out at 1:50 from Fresno City.
That's horrible. I'm so sorry. I'm so sorry. What does a compiler do? We'd like it to be D, right? All right, I'll give you like 10 more seconds to click something. All right, let's see what we're thinking. And then I'm going to stop attendance too right now. I can stop it, right? None of us are going to get dropped? Yes? Yes? Going once? Going twice? We did it. Yay. So we'll just do that at the start of class from now on. All right, a lot of us are thinking C, and that is correct. So it can't be D, of course. C is the right answer. It's like the CPU is the thing that's running your program. The terminal is running your program, however you want to. Depends on your perspective, but it's not A. B is like stores your program when it's run. That's going to be your main memory. Your program's going to get copied into your main memory or your RAM as it's running. And so just by process of elimination, a compiler is the thing. It's a little black box that's taking your code and translating it into machine code that the computer can understand. Okay? That's the goal, eventually. Yes.
Does like, is there any answer like D? Like you know how you have like what does it compile into the answer C? Is there anything that would go like in the question that would like be correct for D or no?
I'm not sure what you mean. Like about peanut butter and jelly?
Like you know how you have like a compiler like C is true for compiler.
Yes.
Is there anything that's true for D or no?
I don't think so. I mean, it depends on the question. I'm sure you could write a question where D is the answer, but it's just a joke.
Oh,
Yeah. All right. I have one last question for us, and now let's see if I messed this up over the summer. So please go not to the ByClicker page, but to the written in-class exercise page, which I will clear out, and who knows if it'll work. But you're in this create/edit post thing, and you can click submit once you're ready. You can change it as you click submit again. But all right, we'll see if this works. I would like you to tell me and write down, please, what is the terminal command to compile a file called x.cpp? If that's its name, what would you do to compile it now that we know what a compiler does? What's the terminal command for that? Do we remember? Type it in there. Let's see if there's a bug in my written ICE page code.
Lon,
Yeah.
do we go to written ICE?
Done. And then also after that, in the same answer, tell me how would you run it after you compile it? What's the terminal command for that? Oh no, it should just okay. Then maybe there's just a bug. Try refreshing the page. Yeah, they probably broke it. It's okay if it doesn't work this time. Let's see. Did I mess it up? Dun dun dun. It works for me. Does it not work for you? Oh, the second you click it, it's supposed to give you a group number though. So yeah, maybe I messed it up. It's okay. So if it's not working for you guys, and I'm sorry about that, I'll try to debug it by next time. If you click the S character, S for shoot, it didn't work, there's a backup written nice page. Try going there and filling in your answer, and just like fill in an open group. Whee. That'll work at least. So that's weird. It only works for me as the admin. I'll try to fix that by next time. So yeah, fill in your answer. Let's see. See what we're thinking. Yeah, it looks like we got the right answer though. Sorry about that. There's always bugs. So, let's see. Yeah, it looks like we got the right answer. So yeah, it's going to be G++, name in the file. If it all works out, it'll create an a.out file, and then you go and you run that with ./a.out. Good. Any questions about that? All right. So yeah, I'll have the real written ice working next time, hopefully. And yeah, the last thing I want to do before our little break, because we're in here till 4:20, I think. Is that correct? We'll have a little break after this, but to end the lecture off on a high note, I have a cute little demo for you guys, and here's what I'll do. I'm going to make the computer sing to us, okay? So here I've pre-made a file called karaoke.cpp, where the computer is going to print out to us, it's going to sing the lyrics to Frozen's Let It Go. Why not? All right, so something I know we all know. So I've done some cool stuff. I've like stolen the subtitles file, and that's how I translated this into C++. But all I'm doing is I'm using something called a function. This is another function. It's called pause, and it stops the program for a certain amount of time. Don't worry about this. I had to look up how to do this. But all I'm doing in this program is printing with cout and endl, which you know. I'm calling this thing called the pause function, which is going to stop the program for a certain number of seconds. It stops it for 20.25 seconds. And then printing and stopping, it's going to print the lyrics to let it go as as it would normally be. Okay? So that's the goal there. Let me show that to you. Let me show it to you running. Let me compile it. First of all, let me compile it with a special thing called -o. All right. If I do this in G++, if I say G++ karaoke.cpp, and I do a -o here, it doesn't have to be called a.out. I can say -o for output as something different. Call it just like karaoke. Call it like a normal file name rather than a.out. Now if I hit enter, it's made this karaoke file, which I can run with a // karaoke. Does that make sense? So that's nice. The -o is cool for that. And now I need to pause the recording, or honestly, I can just stop the recording now. Or no, I'll pause it, because if I play the sound, I'll get like a copyright strike on my YouTube channel where I'm going to put this video in. All right, I think it's working again. All right, so let's come back just for a short while. There'll be plenty of time to talk to each other after I explain things. So let's get started here. I want to get you all on the class server. All right, so if you are on a Windows machine like the one you are in front of you, there's a program called PuTTY that should be installed already. So if you search your start menu, you start typing PuTTY, the first one should be the one that you want. And if you need to install it, that's on the canvas. If you're on your own machine and you're on a Windows machine, SSH Client has a link to install PuTTY. You want the 64-bit x86 version. And if you're on a Mac, actually you have a terminal installed already. So there's a terminal program that you can search for in your little spotlight thing in the top right little thing. You can search for terminal, hit enter, it'll open. So once you're in that, let me show you what to do. So if you're in PuTTY, I'll help everybody once I'm done with all this, okay? If you're in PuTTY, your host name is the name of the server you're connecting to. So it's server.lawtonsclass.com. That's the name of our class server. Everything else is default. Keep it port 22, keep it SSH, that's what you want. Hit open. And it'll ask you, do you trust the computer you're about to connect to? You say yes. And then, let's see, can I make this any bigger? Of course I can. It's not right now. So let me zoom in again. And then it shows a little login prompt. And you're going to give your username and your password here. So just like I said, right now, your username and your password, just like for the class website, it's your last name _ student ID. All right? Even if you changed your password on the class website, your password is still username _ student ID on the class server. It's same username, different account, still set to the default password. All right? So as you type, you're going to say last name _ student ID. I have a test student. Please read what you see so that I don't get too many questions about this. But you start typing your password, you won't see stars. You're going to type your username again because that is what your password is right now. You won't see any stars. It's extra secure. It's getting it still. Hit enter, and it's going to force you to change your password away from that. You'll type your password again, type the new one, confirm it, and then it'll kick you out, and you're going to do the process all over again. So after you change your password, it'll log you right back out. You're going to do the whole thing all over again. Log in, type your username, type your new password, and then once you get to the cow, you're in a good place. Okay? The cow is where you want to be. And so, question? That is on our SSH client page. There's a link to download PuTTY. And I'll come around and help people, and so will Declan once I explain things. So that's if you're on Windows. If you're on a Mac, you have a terminal program that hopefully you just found. If you're there, here's how you do it. You open your terminal program, and there's an SSH command on your terminal. You'll say SSH, your username is last name, student ID, test, well, that one, and then an @ sign like an email, server.lawtonsclass.com, hit enter. It'll probably ask you, do you trust the computer you're about to connect to? You'll type yes, hit enter. Then it'll ask you for your password. Again, you'll type it in. You won't see stars. Hit enter. And then it'll force you to change your password all over again, log you back out. You'll just redo the SSH, and it should work. Dun, dun, dun. It should be happy. All right, so everybody try to get to the cow, and now we'll come around and help you if you're having trouble. This should be most of the information you need. So you got a question? Click it to download it, and you have to run. It's already installed. You should have it installed on the computer. Just search the start page. It'll be there. Yeah, just go to the start page. It's already installed. Search it. Start typing. Yeah, try to get the cow. Oh, no, no, no. You don't install Putty on these computers. It's already installed. Just search the start menu. Search the start menu. Kicking you out. Let me make sure. Give me 1 second. 9129. And help each other if you guys are getting into work. I need to check something to make sure it's not going to lock you all out. On the class website, yes, as well. Alright. That's in. Okay, we are in 29. That's what 29129. 240. That seems right. That seems right still. Okay, good. Cool. Alright, now Give us another couple of minutes. How do you get there? Oh, no. Never mind. Maybe you're on. Is it really not? So on just this computer. On just this computer to be installed. Yeah. Because I think every time you restart, oh really? It wipes everything. Yeah. You know, I swear it should be there. There we go.
Now try to log in. Log back in with your new password. And then from there you should be good to set up.
Get started just explaining the terminal, and then I'll come around and help you guys if you have any more questions. All right, we did it. Yeah, this server, by the way, is located in Germany. Do you think I have control over it? No. If the power goes out in the data center, do you think I can recover the file that you're editing and forgot to save? No. Definitely keep that in mind. Save often. So, yeah, that's why there is some latency when you type. It's still the speed of light. Like you can still, it's still pretty quick, but there is a noticeable lag, and that's why. So, okay, first of all, to save this German computer some computational power, you don't have to do your work on the class server. You just have to get your files on there and turn them in. That's how you're turning in your assignments, right? So you can do your work anywhere if you know how, and I'll help you if you want. To copy your files from or to the class server, you can use a couple of different programs. There's one called CyberDuck, which has a cute little icon, and I'll help you with that if you want. There's also there's one called WinSCP. Let's see here, where do I want to be? There's also a program called WinSCP if you're on Windows to copy stuff. But let me take you through the terminal. All right, let me walk you through the terminal, and we'll do some stuff together, and then I'll let you have free reign for the rest of the time. So first of all, when you get here, you're plopped into your home folder. Remember, that's your tilde. Your home folder has to do with your username. So PWD for print working directory, that shows you that's your home folder. If you ever get lost, you go back out. This is like cd ... Now I'm in the home folder. What's there with ls is everybody's account in all my classes. If you ever get lost, or even cd/, bam, then you can always use cd tilde to get back to where you were. Right? There's always a concept of what folder am I in right now. I'm in my home folder. Right? Right now, if I type ls to see what's there, I do have some things because I was doing stuff in other classes. But for you, let me do the same thing. Way too loud. For you, oops. For you, when you type ls in your home folder, there's nothing there yet. So let me show you how to make some stuff. All right. So let me show you how to make a Hello World program. Let's do it in Nano. All right. I'll show you how to compile and run it. Okay? So, if you say, let me do this. Dun, dun, dun. Now I have two terminals. So if you say nano space a file name like hello.cpp and hit enter, it'll plop you into nano, and that will let you edit files. So let's see, how do I want to do this? Ooh, I have to, oh gosh. Give me a second here. How do I want to really do this? Let me do it without this thing here. So there. All right, so I'll say nano hello.cpp, plops me into nano, and now I can just start typing. It's like Microsoft Word, like Google Docs. So here is, and I'll give you this later. Here is the program. IOStream using namespace standard into main. If you'd like, there's a code from class link on our canvas, and there you can see my Hello World program for real. Because I'm gonna get rid of this for a second. I'm just gonna type it really quick. All right, I'll show you it again. I just need to get through this. Hello World. I think there's supposed to be a comma. You can move around with the arrow keys. The mouse does not work in Nano. And then \n, why not? And then it's got to be return 0, right? You got to do your own indentation in Nano. It's disgusting. Closing curly brace, and that is my program. So if you can't type as fast as me, just stop for a second. To use Nano to save and quit is this stuff. This character is short for control in Nano. So I'm going to type Control X, and that's going to let me save and quit. Control X. And I was like, do you want to save what you just did? Y for yes. What kind of file? What file do you want to call it? I want to call it hello.cpp. That's the file that I'm working on right now. It's already filled out for me. Hit enter. And now, when I type ls, that file exists. I've made it. I can go back into Nano. I can say nano hello.cpp to re-edit it, but it's good for now. Once you've done that, all right, once you...
Sorry for interrupting, but are we like using nano? Like, are we just like are we gonna be using nano, or are you just like showing us like kind of how to use it?
I would not be showing it to you if I didn't want you to use it. All right? Yeah, so you're definitely going to use it. Let's see here. So yeah, there's the file. Let's compile and run it. So we got G++ to compile the program, hello.cpp, and let's save it in a special way into a file, not a.out. Let's call it just hello, -o hello. Hit enter, ls. I've got the file there now. /it to run it, /hello. Bam, I have output is working. And that's that. So in Nano, use Nano to edit. And here's the actual file. There's a cute program called cat to just print the file. You don't have to use that, but that's there it is. So everything from below this line is what you need to do right now. So Nano, G++ to compile, ls to see what's in your current directory. Once you've compiled, you have it /, and here's the actual program itself, these things. That's the actual program that you would type and save in Nano. All right? So after that, if you're happy, there is a better editor called Vim, and I'd like you all to try that. There's a command called Vim Tutor that will teach you Vim, okay? So I'd like you to try that. There's probably not enough time to do it today, but like go back to these slides, use the Vim tutorial to learn the Vim program, the Vim environment. Say Vim Tutor. That will show you a tutorial for Vim. Just like go through it, and it will teach you the better editor than Nano. Okay? So yeah, and then Vim Tutor. And now, for the rest of the time, I know there's only 9 minutes left, but we'll all come around and help you guys.